last lesson, we spent quite a bit of time talking about straight lines. And so let's just have a quick little revision before we get going with new stuff. Here's your question. A line has a gradient of 4 and passes through the point 1,6. What could the equation of this line be? Now, for those who are new, you might be a little bit rusty. We did the format of the straight line is always going to be in this format, y equals mx plus c, where we need to figure out what the gradient is and the y-intercept. See if you can take the information in this thing to figure out the correct option here. Now, I will show you in a moment how to do that, but I'd love you to try anyway. Let's see those answers in the chat, what people think. So I see A's and C's so far. So let's have a look at the way we could figure this out. Please make sure you vote. Even if you get it wrong, I'm not worried. I just want to get a sense of your thinking as you do this. Okay, so what we discussed in the previous lesson was there's two methods we can use to find the equation of a straight line. Both of them will get you the answer, and they're both equally correct. But let me just do both of them now to help us find this answer. So method one, we find the gradient, and we write in the m into the straight line formula. And then we take a point on the line. In this case, the point, we don't have 2 points, we only have 1 point. And we take that point, and normally we write it next to the straight line. And then we sub that point into the equation of the straight line. So since this is x and this is y, we are going to get a 6 here, and we are going to get a 1 here. And then what we need to do is we need to find what that c value is. And because we've got plus 4 on the one side, all we need to do is subtract 4 from both sides. So if I do that, I get 6 minus 4 is c. And the equation of the line, according to this method, would be 4x plus 2. And so that's what I called method one. If you used method two, it's very similar, except we tend to use the structure where we go y minus y1 equals mx minus x1. And all that really is, it's a rearranged gradient formula. Like normally the gradient formula has the x's at the bottom, and it's just that it's been moved to the other side. And then what we do is we write in our gradient, which was 4, and then we need to use a point on the line. And we've got that point, it's 1,6. And so we just go y minus 6. And so you can notice how I've subbed in this bit here. And then here, I'm going to have x minus 1. And then if we multiply that out, let's hope we get the same answer. Add 6 to both sides. Good news is we get the same answer for both, and it's going to be A. Take a moment to look at that. You could have used either of these methods, but I want to make sure that we understand what's going on here. And in fact, I'm actually going to give you another question to practice this. So I'm going to stay open for questions on the screen, but while I'm taking questions, I want everyone else who feels comfortable so far to try and find the equation of the line going through these 2 points. And for those who are new or unsure, think about how you can mimic this process. The only thing you need to do differently is you'll need to be able to find the gradient. And so I'll give you the gradient formula, which we covered in the last lesson. to help you. Okay, so let's go to questions, and then everyone else, if you're not asking a question, you can continue with that. So let's go to Fikile. Fikile, what is your question? Can you unmute yourself, Fikile, and then you can ask your question?
Okay. Sir?
Yes.
I'm asking the first formula.
Yes.
Is it like the first question? I just want to know if they wanted to know which of those will define the line could be. So you are saying the line will be the first letter, which is letter A.
Yeah, that's it.
Okay, it's understandable. Thank you.
Perfect. Let's go to Manda. Manda, what's your question?
Good evening, sir. Am I audible?
Hey, how's it going?
I'm good, and yourself, Mr. S?
I'm very good, very good. How can I help?
Yeah. For the second one, can I ask, when you're dealing with the gradient of, not the gradient, when you're finding the equations of 2 points, is it with the second formula, is it possible to use a simultaneous equation?
Okay. Normally we use simultaneous equations to find what are called intersection points. You can do it to find what M and C is, but my recommendation would be that would take too long. It's almost like, you can do something in different ways, but sometimes there's a faster way. And so my recommendation would choose one of these two ways, rather use simultaneous equations for intersection points.
Okay.
I'm going to stay with that because it is possible. I just think it would take too long, is my honest answer. Yeah.
Okay. Thank you, sir.
Pleasure. Okay, let's see how we're going on this second question. It feels like we need the gradient first. And so I want to know in the chat, what is the gradient that students are getting? So okay, so it feels to me like the gradient is 11/4, but now that is not finished yet. You need to take that 11/4 and see if you can figure out, and you can use either of the methods above, what is the equation of the line going through those 2 points? And I'm going to give you a bit more time for that, and then you can pop your answer in the chat. Let's go there. Fikile, let's unmute Fikile there. I think there's another question.
Evening again, sir.
Hey.
Sir, I just want you to rectify something for me.
Okay.
So if I got my gradient is 11/4, and when I decimal it to 2 decimal place, it gives me 2,75.
Can I give you a tip? Because I know, here's a tip. Whenever you find the gradient, rather leave it in improper fraction form. And here's why. If you round it off 2 decimal places, it's going to have a knock-on effect where your rounding is going to affect the C value. So you've raised a very important point. Leave it improper. You don't have to change it. In fact, generally my advice to students is leave improper fractions like they are and only round off at the very end if you do round off. Okay, so you asked a very good question, and many students will benefit because of that question. So thank you.
Okay, so after that, after getting the gradient,
yeah,
do I have to plot my Cartesian plane?
No, I was just doing that to give you a little bit of a picture of what's going on.
So what are we supposed to do?
Okay, so step one, you've got your gradient. Step two, you write
Yes.
out the standard form of a straight line, which is mx plus c, except you fill in the m.
Oh, I
would-
fill in only the M so that I can find the C.
Yeah. And what do you do to find the c? Can you remember? So all you do is you choose one of the points, and I'm going to choose the point 3, 6 because it looks nice and simple to me. And now I'm going to sub that point
And
into the
fill them Y and the X, and then so that I could be able to get C. Oh, thank you, sir. Thank you. Thank
Yeah.
you very much.
You're on top of things. Okay, so let's see what we get for the C value. What do we get for my C value? I'm going to ask someone else to pop it in the chat there. There's different versions. Some people say minus 9/4. Some say minus 13/4. Let's have a look. So I think C would just be 6 minus 33/4, which is really me just moving this. And what do I get? 6 minus. I get minus 9/4. And so my final answer would be y equals 11/4x minus 9/4, and I would leave it in improper form. And that's that. Okay, let us move on. Not too much. I'll leave that question on the board, but I want to ask another question sort of related to this one. I want to know, just by looking at this diagram, what is the equation of the line shown in this diagram? And I want you to think, is it A, B, C, or D? And you have to use whatever other skills that can help you figure out what it is. Fatejo said, so you can't use both points at the same time. Fatejo, you just choose one point to sub in to find C. And I chose the easier looking point. The one that looked easier to me was 3, 6. And so that's why I used 3, 6 here. So let's see if we can try and do question 7. Now, we're given a straight line on a graph, and so we want to figure out what the equation of this line is. I guess we need two things. We need M and we need C.
Mr. Ace,
Yeah.
we have a question from Linda.
Okay, go ahead, Linda. Let's hear your question. Can you hear me, Linda? Maybe there's a bit of an audio problem there, but no problems. Whenever you can get muted. Okay, I think we've lost Linda there. Fakile, I see there's a question from you. Let's go to you while students are working out the answer to this.
Okay, so
Yeah.
since like on our previous question, we got our Y, well, our C as negative 9/4, right?
Yeah.
So our formula is Y equals to 11/4x minus 9/4. Oh, that is it.
Yes.
Yeah.
That's the previous question.
And then
But now,
going to the next question. The next question,
Yes.
I think, due to my concentration, I say that
Yes.
number C
Yes.
could be our equation for the graph.
Yeah, it'll help you see. Can you see that? Do you know that the C value is the y-intercept? Have you learned about that?
I'm highly aware of that because on a y-intercept, our straight line is going on -1. There it is.
Yeah.
Oh, so it's, I can't say it. And then so on our x-axis is on 0,5. So it depends, is B, possibly B.
Okay, let me see. I think you're right. So let's just have a look. Well, okay, wait, maybe it might be A. So I think everybody, that's fantastic. Thank you for those comments there. Everyone, can you see that the y-intercept is -1? So it could be A or B. The problem is we need to know the gradient, but we're going to get the gradient in a slightly different way this time. Instead of, we could write down the points. So we could take 2 points on the line and work them out, but we can also just count the gradient. So this is a different type of question where it's quicker to just go, well, if I go 1 across and 2 up, then what is the gradient? Well, gradient is just rise over run, or you can say change in y over change in x. But I think I can see that the gradient is +2, right? Now, if you want to do it with points, you can just do it by saying that point over there is the point 2, 3, and this point over here is the point 1, 1. And so if you use the gradient formula, you'll get 3 minus 1 over 2 minus 1, which is 2. But you can also get it by counting, which means that I think the correct answer is A. So why is C the -1? Because I could visually see C is the y-intercept. And so I could just see that it cuts the y-axis at -1. Quick little vote. Thumbs up if you could follow how I did question 7. Thumbs down if you feel a bit unsure about question 7. So, okay, so there's a pretty decent mixture. So in question 7, what was different was that instead of the information being in points, the points are actually on the line. Like you can choose the points, you can work them out just by looking at the graph. So what I did was, the one way you could do it is by choosing these 2 points. And the one point there is the point 2, 3. Okay, so let's just see where 2, 3 is. Here's 2, 3, I wrote it down, and that was that one. Then this one over here is the point 1, 1. Now, if you like, you can use exactly the same process as we did before, where we find the gradient, and we found that the gradient was 2. Okay, and then you would get 2x plus c, and we choose a point on the line. So I'm going to choose the point 1, 1 because it looks nice and simple to me. And if I sub it in, then to get c by itself, I see that c is -1. And so using the process that we used in the last one, we see that it's 2x minus 1. But what I was simply showing you is it's sometimes even quicker to see that the y-intercept in this case is -1. You can see that it cuts the y-axis at -1. So this was always going to be -1, even if I just saw it straight away. And you can sometimes work on the gradient by just counting blocks. And that's what I was trying to show you. Okay, let's go to Lomex's question. Lomex, what's your question?
So my question is, how did you get 2? Because I still don't understand how you got 2.
Okay, so the 2 is the gradient. Are you aware? Are you happy with the fact that m is the gradient, like in a straight line?
Huh?
Is that something that's new to you? Like if I say to you, a straight line is y equals mx plus c, are you aware that in all straight lines that number m will always be the gradient of the line?
Yeah. I'm aware.
Okay, so what I did was I said, okay, well, I can visually see the gradient of this line is 2. That's why there is a 2 here.
Okay.
And then I said, visually, I can see that the c value or the y-intercept is -1. It's down here. And so that's why I could do it so quickly. Does that make sense? But I could also do it the long way by saying, what are my 2 points? They yellow and green. And I worked out the gradient by saying the gradient formula is just y2 minus y1. So like that. And then x2 minus x1. And I got the gradient, which was 2. And notice how it's the same value.
Yeah. Get it now, sir.
All right.
Thank you very much.
No problem. Let's do another one a bit like this, and then we can practice a bit more. So let's do this one. And I will leave this thing on the board. Can you find me the equation of the straight line that goes through these 2 points? So see if you can find the equation of the line passing through these 2 points. Now, you don't have to draw these. I'm going to draw them just to help you visualize what's going on. Let's see if you can. Okay, so if you are lost, my suggestion is start by finding the gradient between these 2 points. Now, there is no picture this time, but you can still work out the gradient using this formula. So let's all start by working out the gradient and then popping it in the chat. Yeah, so it feels to me like the gradient is -2. Well, it didn't feel, I know. So in this process that we're using, we now know that we've kind of figured out this much. Now, because we don't have a picture in this one, in order to find the value of C, which is the y-intercept, we need to do something. And what we do is we choose a point that is on the line and we sub it in. So I'm going to choose the point 3 minus 5 because it looks easier to me, but you could have chosen the other one. And I want to know that if you sub this point into this equation, which option do you think is correct? So let me do this. So -5. And then if I add 6 to both sides, okay. So it looks to me like C is 1, which means the final equation should be that. Is there an option that corresponds to that? It is A. All right. So what we're going to do, the first part of the lesson was all about getting very good at finding the equations of straight lines. And it looks to me like you always have to find M, the gradient, and C, the y-intercept. And we're just going to practice that a lot. The other thing in the second part of the lesson is we're going to look at something called parallel lines and how they relate to this. And so, yeah, but before we can do that, we need to have a break because we've been working hard and our brains can't really go too long without a break. Otherwise, they start forgetting stuff. So what I want is I want everyone standing. So step away from your desk, make sure you've got some space. And we are going to do some unwinding so that our brains can just take a moment off, All right, let's start with some nice deep breaths. So breathe in, breathe out, and out. One more. And out. Okay. Let's start by just stretching a little bit. So from side to side, kind of loosely. And then as you feel more relaxed, you can turn a bit more. You should hear a few clicks. And then let's also just shake it out a little bit so we loosen up our shoulders. And if you're the jumping around person, don't let me stop you. Be the best you can be. And then let's roll the shoulders. So 1, 2, 3, 4, 5. And then 1, roll forward, 2, 3, 4, 5. All right, and then let us do some air skipping or some. And so pretend you have a skipping rope in your hands. And what we're going to do is we're going to do 30 of these. So make sure you've got some space. Go in 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 19, 20, 21, 22, 24, 27, 28, 29, 30. And sit down. And for this, I hope that that was good for your heart. I hope that you feel awake and that the blood is pumping. And then for those students who are new, we play this little game called Maths 24, just to give ourselves a break between parts of the lesson. So the way it works is you need to use these 4 numbers on a card and try and make 24. But you can only use each number once, and you only get to use the operations plus, minus, times, divide, and brackets. And so if you just watch how the students do it, you'll see how it works. Ooh, okay, 5 times 3 plus 9. Andile, have you got... there's 2 ways of doing it. Okay, the red card, 5 times 3 is 15, plus 5 plus 4 is one way of doing the red card. And the other one way of doing it is going 5 times 5, and then minus 4 minus 3. So both of those will give you 24. Okay, so the red card has already fallen to Samile and Rafense and Andile. Can we try and do the blue card? Can we make 24 using the blue card? Who has some answers and options for me? We're getting quite good at this Maths 24. I'm happy. Let's have a look. Clonolo, let's go to you. Can you tell us how to do the blue one? Do you have an answer for us? I don't know if you can hear me. Maybe there was a bit of a...
Hello?
Hey, can you do the blue one for us? Have you got an idea?
Yes, I have an idea.
Go for it.
Okay. 6 multiplied by 3 is 18.
Okay.
Then 5 plus 1 is 6.
Yes.
Then 18 plus 6 is 24.
Perfect. Yes, well done.
Thank you.
Okay, one more, then we must go back to the lesson. Oh, wait, let me get rid of this one. Let's see if we can do the yellow one. Can you make 24 using these yellow one, these 4 numbers that are yellow? This is a bit tougher. I'm only going to give you a minute or so, but you've done so well. I feel like I have to give you a 3-dot card. How might we be able to do? You guys are getting so good at this. So I think a very clever thing to do, and this Rafense has spotted this, is go 5 plus 5 and put a bracket around it. And then what happens? So you use the 5 and you use this 5. What do I do next? So I think Rafense has got it. You go 5 plus 5 is 10, and then you say times 2, and then you add 4. That gives you 24. Well done, everyone. So I really loved your participation and enthusiasm. And I also love that we're secretly building our math skills in the background, even when we're having a break, which is fantastic.
Nicely done, guys.
Well done, yes. Let's go back to what we were doing before the break. And I want to ask you to look at these 2 straight lines for me. And I want to ask for some comments about these 2 straight lines. So what do you notice about these 2 straight lines that are on the screen right now? I'd love someone to put their hand up and they can tell me something about them. Or you can put it in the chat. So let's go to Manda. Manda, what do you notice about this picture on the screen now?
Hey, sir.
Okay.
I noticed that they share the same gradient, if I'm not wrong.
Okay, how did you spot that?
So what I was told is that parallel lines, they share the same gradient. And I can see by the equations of the straight line, because they say y is equal to 2x, and the other, for the green, it also says y is equal to 2x, meaning the 2 has the same gradient.
Yep. So because when lines have the same gradient, they will be parallel. And in this case, you can actually see it in the formula. The other way you could have done it is just by looking on the graph too. You can see that you go across by 1 and up by 2. The same thing here, but you're spot on. So the gradient is 2, and when lines have the same gradient, or parallel lines have the same gradient. Fantastic. Thank you, Manda. Another thing I want to point out is that if I wanted to draw another line parallel to these, all I need to do is choose 2 points that have a gradient of 2 between them. And if I draw a line with a gradient of 2, which I'm trying to do right now, you will notice that this line is also parallel to these ones. And all I did is I made sure that the gradient was 2, and then the lines are parallel. Okay, so parallel lines have the same gradient. So how can we mix this into a straight line question? Well, let's try a nice simple one to start with. If I had a line parallel to y equals 3x plus 4, what would the gradient of that line be? And you can choose A, B, C, or D. Tell me what you think. Okay, nice answers coming through there. There's a couple of A's and a couple of C's, which is good. Because this is in standard form, we can just grab the gradient straight from the straight line, and M would be 3. And so the correct answer would be A. So the gradient of this, so because the gradient of this line is 3, a line parallel to this line, so let me even just draw this with you quickly. So plus 4 is the y-intercept, so we know it goes through 4. It's basically a line that it goes through plus 4 on the y-intercept, and it has a gradient of 3. So like that. And we know that any line which is parallel to this one will also have a gradient of 3. So the answer is A. Okay, so that is the first type of question. Let's try a slightly harder type of question. Well, not hard, but harder. Determine whether or not the following 2 lines are parallel. And I want you to give you some time to think about this. And then I want you to tell me, are they parallel or are they not parallel? In fact, let me even have a vote first. I want you to guess. Do you think they're parallel or not? Put it in the chat. Some people say no. Some people say yes. What do we need in order to determine whether they're parallel? What would I need to find in order to determine if they're parallel or not? We would need the gradient of both, yes. Now, at the moment, if I rewrite this one actually is in standard form. It's just that we're so used to this being on the right-hand side. I want to suggest the gradient is -2 of this one. But what's difficult is I don't know what the gradient of this line is. And so what I want to suggest is if we change this to standard form, we then know that the gradient of the red one is also -2. And so because the gradients of lines are the same, they're parallel. So we're going to say parallel lines as gradients equal. So if you want to figure out whether lines are parallel, you just need to look at their gradients. You can either use the gradient formula, or if they give you equations, you just put them into standard form. And that's all you need to do. Yeah. Okay, so using this idea, let's have another go at a question like this. Determine whether or not these two straight lines are parallel. Over to you guys. You can tell me in the chat. Keep those answers coming, everyone. Keep those answers coming. So the first step is you need to write this in standard form. And what you notice is that the gradient for the blue one is +1. Sorry, the gradient for the black one is +1. The gradient for the yellow one is -1. And because the gradients are not the same, they are not parallel. And you could just say gradients not equal. Okay, so this is quite a nice, easy thing to do and apply. Yeah, Manda, let's go to you. What's your question?
So can I ask about those two lines?
Yes, go ahead.
Do they bisect each other? Do those
Okay.
two lines bisect each other?
They don't bisect each other. They are, I'll explain. They do have a relationship. They're just not parallel. But I'm going to get to that relationship a little bit later. So for now, I'm just going to say they're different. Therefore, they're not parallel. Okay.
Okay.
I want everyone to try and figure out whether the line passing through these 2 points, whether or not it is parallel to this line. So there's I'll call it the blue line and the green line. I want you to figure out, and I want you to think about what you need to figure out and then try and do it. And then I'll take questions from students as you think about it. But for those who feel comfortable, go ahead and tell me whether these lines, the green line and the blue line are parallel or not. Okay, Fakile, what's your question?
So they're asking the line passing through points, right?
Yeah.
So we are supposed to use any of this y-axis and x-axis to fill in the formula that we are given so that you could be able to reach out to the answer, right?
Yeah, but I want to ask you for the blue one. What do you think we should find first? What do you think will help us in figuring out whether a line is parallel? What do you think we need to find?
Yes, we'll find the gradient.
The target, yes, but would the target not be the gradient? Isn't that what we're looking for? Because if we know the gradient, we know whether or not they're parallel or not.
It will be able to show us if our things are parallel or not parallel.
Yeah. But now I want to ask you, how do you find the gradient between 2 points?
Between the 2 points, we're going to use those points using m is equals to y2 minus y1 over x2 minus x1.
Exactly. You're spot on. So we're just going to use those 2 points. So we go. And for the blue one, we seem to get -2 over -2. So the gradient is 1 for the blue one. And for the green one, all I'm going to do is rearrange the subject of the formula. So I'm going to bring the y to the other side. And then it feels to me like the gradient is 1 in both cases. So we can say lines parallel. Lines are parallel because gradients equal. And that's it. Fantastic. So I feel like we are really getting on top of parallel lines. And so what I'm going to do is I'm going to take you into another type of question where you have to use your knowledge. Let's do this. Let's do these two. So, okay. Now, I want to ask you what is different before we start this question. What is different about this question compared to the last one? I'm going to read it through once with you. Write down the equation of the line that is parallel to y equals 6x plus 1 and passes through 0, 8. How is this different to the previous question? And what, yeah. Only one pair of points, yes. Okay, so the previous question, so in this case, we only given this point. One coordinate, yes. We're not writing whether it's parallel. Yes, they say that it is parallel. We don't have to work it out. What they want is they want us to write down the equation of the line that is parallel to this line and passes through the point 0, 8. So what do we need to do? Well, in order to find the equation of this other line, we need to find M and we need to find C. So what is the gradient of the other line going to be if we know it's parallel to this one? Yeah, it has to be 6. So that's easy. And then we know that we could do this. We could say, look, y is equal to 6x plus c. Some of you will have noticed that this is the y-intercept. If you've noticed that, then you're good to go. If you haven't, all you need to do is take that point and sub it in. And so if I sub that in, I get 8 is equal to 6 times 0 plus c. And anything times 0 is nothing. And so 8 is c. And so we get y is equal to 6x plus 8. So in this way, they can ask you to find the equation of a line, but use the relationship of being parallel. So I just want to have a vote. Thumbs up if you understand what I did there to find the equation of the line. Thumbs down if you didn't understand. Okay, so there's a bit of a mixture. What I want is those students who feel comfortable, I want you to try and do this question over here. Those who are uncertain, we're going to talk through this question here slowly, but just see if you can do this one. So this next one. All right, let me take questions on the previous one for those who are feeling unsure. Let's go to Mpumelelo. Yeah. What's your question?
Morning, afternoon, sir.
Hey, how can I?
I'm good. I wanted to ask about the previous question.
Okay.
That when we had to find the C, right? We had to subtract the we had to subtract the -2 to leave the C alone, and then we had to subtract the -2 from the -1.
Okay, yes. Let me just zoom up. So are you talking about this one up here? So this one?
Yes, sir.
Okay.
So I wanted to understand that if we subtract the -2, do I have to like say -1 minus in brackets the -2, or is that going to change my sum?
Okay, so you're trying to work out the gradient, and when you do that, are you choosing to start with the -4 -3, or are you starting with the -2 -1? Which point do you start with?
I started with the -2, -1.
No problem. So you start and you go -1 minus -3. That's what you should have
Okay.
done, because you're subtracting the y's, and then you must start from the same point and you go -2 minus -4.
-4. Okay.
Okay, so now what happens is you get -1 plus 3, and then below that you have -2 plus 4, and now -1 plus 3 is 2, and -2 plus 4 is 2.
2
So your gradient is
is
1,
1.
which is the same as what we got last time.
Yes.
Are you happy? Does that make a
Yes.
bit more sense?
Yes, thank you, sir.
Pleasure. Okay. Let's go to Kat's question. Can we unmute Kat? Kat, what's your question?
Hi, sir.
Hey.
So I wanted to ask about the same question that she asked about.
Yes.
So when it comes to like these kinds of questions, is our goal to prove that our equation is going to equal to the one that they give us?
Okay. There's two different, so in the earlier part of this lesson, I was asking you about two lines and whether or not they were parallel. And what I was doing was I was finding the gradient of each of the two lines and comparing them. So in the one I was just discussing, I found that the one gradient was 1, and then I found that the gradient of the other line was also 1. And because the two gradients were equal, I could say they were parallel. So that's one type of question. So determining whether the lines are parallel or not, we look at the gradients and we compare them. If they say to me lines are parallel, find the equation of the other line, like the question we're trying to do now, that's a different type of question. And so it has a slightly different structure. So can we look at this one together now, and I'll show you how it's a bit different. Okay, I think I'm
Okay.
I'm still, are you with me? Okay, so if we look at this next question, determine the equation of the straight line that goes through a point and is parallel to y plus 2x minus 1 equals 0. Can you see how there's no question of whether it's parallel or not? It's just a question of find the equation of the line. Okay, so I want to ask you, if this is a
But then
straight
in this
line,
one, must they give us the...
what would you do to the straight line to help you, to make your life easier? What do you think you would do to this over here? I was thinking, shouldn't we just put it in standard form? So we go y equals minus 2x plus 1. So we've moved that across. And from that knowledge, I now know that the gradient of this line is minus 2. But this is not the line I'm after. But what it does help me is the line that I'm trying to find must also have a gradient of minus 2, because they are parallel lines. So there's two lines and they're in a relationship together, and we know that they're parallel. Once you know that the gradient of the one is minus 2, the gradient of the other one, sorry, I drew that the wrong way around, but we know that these would have to be equal. So that's how I know that that's minus 2. Then what I'm going to do is I'm going to write this out. I'm going to choose a point, but I actually don't even need to choose because there is only one point. So I take 1 minus 5 and I sub it in to this equation. So I just want to have a look at the chat. Who has the answer already? Maybe give you a moment to put the answer in the chat if you've got it. Before I so I'm going to sub this minus 5 is a y, so it goes. And this is an x. So the equation of the line that I'm looking for is minus 2x minus 3. And in order to figure out the equation of this line, I had to first figure out the gradient of the first line. I then hopped across that minus 2 to my other line, and then I used the point on that line to help me. All right, I'm going to take, what I'm going to ask is I'm going to take questions from students who are unsure, but while we're doing that, those who feel comfortable, if you could just fill in the poll for tonight. So Lebo, if you could just put the poll up for students, and then let's go to Ntando first, because I know you have a question. So let me unmute you. Ntando, where is your, put your hand up, Ntando, and we can unmute you. Tebogo, let's go to your question. Tebogo, what's your question?
Hi, sir.
Hey.
For this question, why can't we say y is equal to 2x minus 1?
You can't say it's 2x minus 1 because when you took it, so at the beginning, the green graph or the green equation isn't in standard form. And so I had to move the 2x to the other side. And when I did that, it became negative 2x. And I also had to move the minus 1 to the other side, and it became plus 1. And so you can't extract the gradient until it's in standard form. Does that help?
Yes, sir.
Pleasure.
Thank you.
Cool. Let's go to Tova. Tova, what's your question?
Hi, sir.
Hey.
I just wanted to ask, for the previous question, we said that we can make C equal the Y coordinate that we got. Is that because X equals 0? Does it only work when X is 0?
Yes. So when X is 0, it knocks out the X term. So basically, whenever X is 0, that point, the Y point will be the Y intercept. But students don't always spot that, and that's fine because even when you sub that point in, you still end up with the right answer.
Okay, thank you, sir.
Cool. All right, any final questions before we wrap up tonight? Lolo, that's completely fine using the other format. As long as you're getting the same answers as me, it's completely fine. I try to show that both methods are fine, but obviously because of time and space on the board, I kind of just went with the method that most people seem to be using. Okay. Everyone, you have been fantastic, working hard on a public holiday. I want to salute you for all your hard work. It will pay off. And I will see you on Wednesday. I do hope that you have a good rest of the week. And please, if you are new, do have a look at those 2 previous lessons, because in the next lesson, we're really going to build on the gradient idea. And so it's important that you have a good understanding of gradient for that lesson. All right, Lebo, if you could just take a screenshot. Is there anything more from you? Otherwise, I think we can call it a day.
Nothing from my side, Mr. Eames. Thanks
Sorry.
for all your hard work, guys.
Pleasure. What, there was some student, Owetu, what, do you have a question? Is your hand up? Oh, there we go. Okay, Owetu, let's see if we can help you before we finish off tonight. What is your question? Owetu, can you hear me? I don't know if there's some problem. I think maybe there's an audio problem there.
Can
All
you
right.
hear me?
Oh, I can hear you. There we go.
Okay, I just disconnected from my headphones. I do not know what is going on. Anyways,
Yeah.
can you please just scroll up for me?
Yeah.
Just for a bit, just to that previous question. So you see how we're trying to look for the four, wait, no, yeah, that one right there. You see how we got
Okay.
our C value?
Yes.
Our C value, it is 4. I want to know how we got to that point. Just want to
Okay,
make sure. Yeah.
So if you look at this bit here, oh, let me make it bigger. If you look at this bit, it's not in standard form. So if you have to put it in standard form, all you need to do is move this y to the other side, and then it becomes x minus 4 equals y. And so is this the question you're asking about? Let's see, can you hear me? Okay, I think we're having some audio issues. Okay. Tell you what, let us maybe just come a little bit early to the next lesson, and then we will have a look at that. I don't know quite why things have gone wrong, but we'll wait to just remember at the beginning of the next lesson, and we'll go from there. Unless what? Are you mute? Okay, unmute. Okay, quickly. Oh yeah, let me unmute you then.
Oh yeah, sorry. I muted myself so I could let you speak. So
Okay.
yeah. Anyways, so yeah, that was the question. You're doing it correct.
Okay,
Exactly.
so all that you need to know is that if you wrote it like this, okay, then the C value is always going to be that value there, the minus 4, and the M value is just the number in front of the X. So it's just basically putting it into standard form. That's all. Okay. Sorry, guys, we have run out of time. So can I suggest, Fakida, I'm sorry that we couldn't get to you now, but we will continue in the next lesson, and then we will go on from there.